Alrighty, thank you for that introduction. First of all, how many people here are doing cross-platform development with C++? Just show of hands. Wow, a lot of you. Perfect. Well, good news. You came to the right talk. I know there were a lot of choices during this hour, so I'm glad you decided to come to this one. Obviously, I'm going to be talking about some of the challenges with cross-platform development with C++, and then hopefully show you some tools that maybe you don't know about yet, or maybe ways that you can use them that you're not aware of, and how that can help your life. But before that, just to reiterate, I'm a program manager on the Visual Studio for C++ team, and I have a focus on the productivity features. So after the talk, if you have any recommendations for how I can make you more productive in the IDE, definitely let me know. And then obviously, if there's cross-platform questions, let me know that as well. But our Visual Studio team was at CPPCon about a month ago, and while we were there, we were talking to a lot of the developers there who were doing cross-platform work. And we tried to identify what were some of the big challenges that people were having when they were doing this. And here's the list that we came up with. Hopefully, yeah. All right, sweet. So there's libraries, building, compiling, debugging, and testing. All these were frequently mentioned. And actually, it seemed to me that debugging was the big one that, well, when people were bringing up challenges and we were like asking about them, everyone's raising their hand on debugging. So I'm going to go into quite a bit about different debugging scenarios and how you can hopefully use some tools to help with that. So let's get started first with the libraries part. So some OSs, like Linux, for example, you have system-provided package managers, which is great, except that a lot of times you'll have many, many of these package managers, and you have to keep track of which one you're supposed to use with which distro, and it can get kind of confusing. And also, a lot of times these system-provided package managers are optimized to work well with the OS, rather than necessarily being optimized for the libraries themselves. So you'll oftentimes find that they'll have older versions of libraries. So if you're trying to stay up to date with the latest and greatest, that might not be the best route. Sort of on the flip side of the spectrum is manually managing from source. So that's awesome because you get complete control over what you're doing. It also kind of stinks because you have to have complete control over what you're doing. So you've probably already read the third bullet point by now, and that's Vcpkg. And so that's Microsoft's sort of aim to find a happy balance between the two of these. So how many of you are aware of Vcpkg? Oh, nice. About half of you or so? Well, for the other half, you're going to learn something today, so that's awesome. Vcpkg is a C++ package manager. It's made by the Microsoft team. It's open source. It's on GitHub. I'm going to show you how to use it. It's really simple. But for now, just know that it exists. And the last bullet point is actually more on compilers. So compilers are becoming more consistent with supporting the standard, probably because MSVC is better at that now. So that's good, but oftentimes in practice, you might be targeting like an older version of Windows, for example, and some of the new compilers might not have support for that yet, so it can get a bit hairy as well. For those of you that are maybe new to cross-platform work with C++, you might not have heard of CMake, but CMake is basically like the de facto build system for cross-platform work at this point. But even still, if you look into CMake projects, you'll find a lot of platform-specific logic in there. So you'll have platform-specific logic around which compiler to use, or throughout the code, you'll find if-defs, things like that. And actually, before Vcpkg was a thing, and when I was looking for some cross-platform projects to use, a lot of these projects will have a lot of lines of code with logic around which dependencies you should be using for which platforms. And Vcpkg will make that easier by getting rid of a lot of that platform-specific code. Then MS Build is the next one. Obviously, it's great if you're targeting Windows. And actually, while we're talking about Windows, how many of you knew that CMake is natively supported in Visual Studio on Windows? All right, about 2/3 of you. Nice. So yeah, a lot of people think they have to generate projects and solutions with their CMake projects to work on Windows, and that's just not true anymore. You can open up an arbitrary file of code, folder of code, and as long as it has a CMake list.txt file in there, Visual Studio will detect that, and it'll start lighting up things in the IDE to get your project to work. Lastly, there's Make and then other build systems. These don't have quite as nice integration in Visual Studio just because they're not quite as popular, but you can get them to work with a bit of more configuration. Alrighty. Last few challenges here is testing and debugging. So testing, I'll go a little bit into unit testing, and just quick, another show of hands here. How many people rely on a CI system for their cross-plat tests? Yeah, that's what I thought. All right, Cool, good to know, thanks. All right, and then lastly, I'll show debugging on Windows and Linux and a bunch of different debugging situations with that. But that's definitely enough slides for now. So we are gonna start going heavy into demos. I'm gonna show a lot of the different tooling to help you with this, so buckle up, because we're going for a wild ride. I got a VM here, we've got Linux running. I started this up with Hyper-V, super awesome program, I highly recommend it. It's really easy to spin up a Linux VM using it. And what I'm going to do is, first, since we talked about Vcpkg, I'll just show you how to get that super quick. All you need to do is, like I said, it's on GitHub, so you just go git clone, https, github.com/Microsoft/Vcpkg. All right, so you'll clone that. I've already done it, because I figured you wouldn't want to watch me do that live. And once you have that installed, you'll see there's a bootstrap file in there. You're going to need to run that .sh. And if you're on Windows, the setup's the exact same. You're just going to run the .bat. Super simple. The setup's really similar whether you're on Linux or on Windows. I've already run that bootstrapper, so I should be good to go. The project that I want to demonstrate the first set of features on is Pong. You might have been able to read that folder there that says Pong, a little giveaway. But it's a cross-platform game, and it depends on this library called SFML. It's a cross-platform graphics library. So I'm going to just see real quick if Vcpkg has that. So Vcpkg search SFML. And what this is doing is it's actually searching, since I cloned the repo, it's just searching, it's not reaching out to the internet or anything, it's just searching in my local files here. And I see SFML. So looks like that's exactly what I want. So I can just simply run install, or Vcpkg install SFML. Happens lickety-split because I already installed it. But when I was doing it live, it took, I think, around 1 minute or a minute and a few seconds. So it's pretty quick. And you'll notice here that down at the bottom, there's something nifty for us if we're using a CMake project, which I am. It actually gives you this snippet of code right here that you'll use in your CMake list in order to set up your libraries without any sort of really intense platform-specific logic. So keep that in mind. But before we can actually start using this, I want to do, Vcpkg integrate install is the final command that we need to run. All right. Did not spell Vcpkg correctly. All right, so again, integrate install. And if I'm on Windows with like your traditional solution project, MS Build project, and I ran that integrate install, all my projects would be able to immediately start accessing that SFML library, like no questions asked. Just that integrate install command there is like magic. With CMake, it requires one extra step, but it's still not a big deal because Vcpkg is nice and it gives us this toolchain file right here. So I could just run CMake and then paste that toolchain file there, and then run make, and I've built the project, but I don't want to do that right now because I want to take a second to show you how to set this up with VS Code, because for those of you who don't know, VS Code is a cross-platform editor. And so I'm just going to open up my Pong project in VS Code, and I'm going to show you how we can set up a CMake project on Linux to run in VS Code so we can still do like editing and debugging and things like that. All right, so we've opened it up, and without doing any sort of configuration, you can see I've already got some, oh, I need a password. This is for something later, but. All right, so I haven't done, wait, why is this already set up? Hold up. Let's just totally delete that. Got to make sure we start fresh here. All right, let me just extract this thing. All right, let's try that one again. So we'll go into VS Code. And as we saw before, and when this loads up, you'll see a lot of colorization already. And all I have in here is this. I got two extensions that you should know about. So I have the C++ extension, which is made by Microsoft to get the IntelliSense. And then I've also got this CMake tools extension, which is going to make our life a lot easier because this is a CMake project, and we'll see that in a second. So if I go down here, you can see if I hover over ball radius, I'm getting quick info telling me that it's a float. And if I were to start typing, for example, BA, I get autocomplete there, tells me ball, then dot, I'll get the member list. So all the IntelliSense is already working without any sort of extra configuration. Yeah.
Possibly make your VM full screen so it's a little easier to see?
So I wish. For some reason, when I do full screen, it actually just keeps this the same size, and it just makes the borders black. I'm not sure why, but maybe I can just make the font bigger. Thought I could just control scroll, not a thing. Oh, that made the whole thing bigger. That might be helpful. Are you able to read this?
Yes.
Okay, cool. So what I need to do now is, IntelliSense is working, but I want to actually set this up to be able to build with CMake. So if you do Control comma, that'll open up this settings search here. And I'm just going to search for CMake settings. And this first option here, configure settings. So this is actually going to be the CMake variables that you would set on your command line. It's exactly what I want. So I'll click this edit in settings.json. Go workspace settings. And I like to just copy this chunk of code here that's on the left and just paste it over here to make my life easier. And all I need to do is just go back into that terminal where I had Vcpkg, and it gave me this toolchain file. And I'm just going to first copy the CMake toolchain file part of that variable name. And then follow that with the path. And then the last thing that I want to do is just specify a build directory, so we can just do cmake.build directory. There it is. And it's going to default to this workspace/build. Now, make sure I got that folder in here. Let's add a build folder in there. All right. Cool. So with that configuration, I'll save. We should be able to build now. So down at the bottom, there's a build button, which was generated by that CMake tools extension, like all the stuff down here. And we're building. Let me see if I can make that bigger. Yeah. All right, so it built successfully. That's awesome. Let's see, close out of this. But let's say I want to do some debugging. So if I scroll down to line 161, oh, I've already got a breakpoint there. So let's say I want to put a breakpoint at this line where it says you lost, just because I know that that's a breakpoint I can hit because I will for sure lose. So if I now click on this debug button at the bottom, now we can actually debug this application. It's in Linux, running on VS Code. And all right, the game has started up. Click space to play. Let's do this. All right, so I hit the breakpoint, worked perfectly. So now I'm debugging on Linux. Everything's nice. I've got the variables, locals, watch, call stack, everything. All right, that's pretty sweet. I'm going to stop debugging for now. That was all in Linux, but I know that a lot of people are actually developing on Windows, and you're familiar with your Windows environment. You like the richer debugging experience of Visual Studio. So let's switch on over, take that opportunity to switch on over to the CMake support in Visual Studio on Windows. So if you aren't aware already, you can now open folder rather than open project solution. And we'll go in, open up this Pong folder. So this is the same code base. All right, and you can see over in the Solution Explorer, we have folders now. You can also see we're getting an error down here, and that's related to the SFML library. Can't find it, and that's because I haven't done the Vcpkg step over here for CMake. But luckily, it's the exact same process. I already have Vcpkg on Windows, so you just go Vcpkg integrate install in order to get that toolchain file. So copy that. And this is actually really nice here. So I just want to make sure I set up my configuration. I'm going to choose an x86 debug. And it generates this boilerplate. We don't care about most of it except this CMake command args. And that's where we just paste that entire string in there. And we can save. And now down in the output, you can see the target info extraction is done. So now, if I go into Pong, I should have, yeah, so I'm not getting any sort of red squiggles on this SFML header here. I can hover over. You might not be able to see, but it's coming from my Windows directory, so that's all working now. So now we've got a CMake project set up, and I already know that my breakpoint should be on line, I think it was 161 from VS Code. So I could scroll down to that, or I could be an absolute legend and use Control-T, followed by, well, first of all, if you do Control-T, which is go to, and then you type a question mark, it'll show you the different filtering options you have. So if you do a colon, you can search line numbers. If you want to just search for files, you can just type F and then the file name. We're going to do the line number one, though, so colon 161. All right. You're right, I'm not in my almost was legendary. All right, there we go. And then I can just do a breakpoint with F9 or click over in the side of the editor. Let's see if this works. So I'll choose my Pong project. So again, this is now a CMake project on Windows with Visual Studio. And it's a CMake project that we're able to now debug. It launches here, obviously on Windows. And when I lose, I hit the breakpoint. But you know what? I'm tired of losing. So if I just drag this instruction pointer down to line 166, and let's go ahead and continue debug. Oh, all right, I'm a winner. So I've shown that I can win on Windows at Pong, so that's awesome. But I still wasn't able to win on Linux, so now I'm going to show you how Visual Studio is going to help me win on Linux in the game of Pong. And the first thing that you need to know how to do is set up a connection to that remote Linux machine. So I could be like a decent programmer here and go to Tools, Options, and then go to the Cross-Platform tab, and then go to Connection Manager. Or another legendary tip here, this Quick Launch menu that not many people know about up in the top, and it's cropped, so that's awesome. But up in the top here, if I just type Connection Manager, which is what I'm looking for, if I spell it right, not connectoin, yeah, there we go. So it shows me down here that exact option, and so I can just click that, and it takes me to exactly where I would have gone if I went to Tools, Options, Cross-Platform, Connection Manager. So the Quick Launch menu, which you can also get to with Control-Q, is a super awesome way to navigate to your different options. So I've already got it set up here. You can see I have a connection to that Ubuntu. But if you want to add any other remote connection, it's as simple as clicking that Add button. Then I typed in my IP address and the credentials, and it'll just put it in this list. Now, one new thing here is Remote Headers IntelliSense Manager. So now that I've established that connection, it's actually going to be able to pull the system headers and now also the Vcpkg headers from that remote Linux machine into Visual Studio to give me the highest fidelity IntelliSense experience for Linux while I'm in Windows. So I'll show you that as well. But now that we've set up the connection, we can go ahead and manage that configuration, or add the Linux configuration. So we'll go again into the CMake settings JSON, right-click, add configuration, and there's quite a few options here, but I'm going to choose this Linux debug. And again, it generates a similar amount of text here. Just a couple things to be aware of. The CMake executable on my remote is actually in a slightly different spot, so let's edit that path real quick. No biggie. And then we have that familiar CMake command args field right here. But we're not going to put that CMake toolchain file that we got in the Windows command line, because this is for our Linux machine. So we actually swing back on over into Linux, grab that toolchain file, copy, and just paste that in the command args here for our Linux configuration. And we should be good to go here. So I'll just switch my debug over to Linux. IntelliSense is now going to start gathering information based on that connection down here. And so all you need on your Linux machine is SSH, and if you have rsync, it'll speed things up. So looks like, all right, so the configuration to Linux debug is now complete. And I've got Pong here. OK. And let me just double check. Yeah, all right, so I got a breakpoint. So let's go ahead and try to debug this thing. So now I'm in Windows on Visual Studio, but I'm targeting Linux, OK? And if all goes as planned, we should get an error. There we go. Nice. So I knew this would happen, and that's just because this is a GUI application, obviously, and so it doesn't actually know. You'll see it's failing in this create window part of the code. It's because it doesn't know where to render these graphics. So if this had been like a command line project, this would not be an issue at all. But no worries, I was prepared for this. So if we just swing over here and do echo display, we'll get the necessary information to give Visual Studio. So it looks like it's :10.0. So let's stop the debugging session here. And if I right-click on CMake list.txt, I'll just go into the launch settings for Pong, just to let it know what display to use here. And you'll find that down in pipe args, right in front of this debugger command. We'll type export display equals, it was :10.0. Let's not screw it up. There you go. Save that. And we should be able to now successfully debug this thing. So again, it's copying files to the remote now. It's doing the build on Linux. It's not cross-compiling. And there we go. The process is now started up on our Linux VM. We can go ahead and play. And once again, I lost, hit the breakpoint. So now you just saw me targeting Linux. I launched the process on Linux. It was built on Linux. And let's see if I can also win on Linux here. So I'm debugging, drag it down, and I'll continue. And there we go. I'm also a winner over there. So all the debugging is also working as well. Pretty nice. Stop the session right now. All right. One other thing I want to point out here, so you'll remember when I was in my x86 debug, I opened that sfml graphics.hpp document, and it was kind of hard to see, but when I hovered, you could see that it was coming from my Windows directories. So now, though, I'm in my Linux debug. If I open up this graphics HPP, now you'll see it's coming from my Linux header cache. I mean, you probably can't see it, but it does say that, I swear. It's coming from my Linux debug header cache, and you can actually see the path to it from that remote machine. So I'm actually getting that header from Linux. And for just the sake of it, let's switch back to x86. Let's say you're on your Windows machine, you're thinking about Windows, like you do cross-platform work, but you're not necessarily always thinking about Linux. And you want to do sleep or something like that. So you include windows.h so that you can use sleep. And oh, what's that? What just showed up there? We're getting a squiggle on that include. But why? Well, this is a purple squiggle. All right, there you go. And if I hover over that, it's telling me that my Linux debug, because it's aware of my configurations. I have my x86 debug, but I also set up that Linux one. And it's telling me that Linux doesn't know what to do with this. It can't open windows.h. And similarly, if I were to go down here and type sleep from there, that's also going to give me a purple squiggle and tell me, Linux sleep is undefined. All right, and sure enough, if I were to switch into my Linux configuration, those squiggles actually become red squiggles once I'm in that configuration. So this is platform-specific IntelliSense. I didn't even have to build, and it's helping me out as I'm writing my code, and I'm maybe not thinking about Linux or not thinking about whatever other configuration I have set up. It's actually going to help me out and let me know how my code will react in those different situations. So that's a feature I think is underrated and awesome. So definitely take advantage of that. All right, let's see. I think that's the last bit of Pong stuff that I want to show in Visual Studio 2017. So I'll go ahead and I'm going to open up another project. This is Bullet, which is a much larger project, so it doesn't just have one source. You can see I have open folder mode enabled on this, and we'll get into that in a second. I'll actually go ahead and, so also up in the top, because it's a CMake project, you'll notice there's a CMake menu item there that was generated, so you can actually build. So we're building this thing live, so let's hope that works out well. And in the meantime, I'm going to, because this is Pacific++, I'm going to swing on into some really early Visual Studio 2019 to show you one more feature, cross-platform related. What could go wrong? And we'll go into Pong here. Come on. So yeah, these are some really early demo bits, but I just really wanted to show this feature. So let's hope it works out. All right. So you might notice, actually, it doesn't look like you can see it, but if all right, let me just back up for a second. Let's say you're on Windows, you're on Visual Studio, and you're running into some trouble. You want to have your teammate help you out with your code. But maybe that teammate's on Linux, because this is a cross-platform talk, obviously. And you could, as I forget who the speaker was, you could like print out your code, send it over to them. Or you can use this awesome new feature that's going to be new for C++ in 2019 called Live Share. So if I go to File, Start Collaboration Session, if the internet works, it should generate a link for me that I can then send to my teammate, and they'll be able to hop right into my editing session without having any of the source locally on their machine. They'll just get it from me. All right, so it looks like the link was generated. So now if I swing into Linux, let me actually open up a new window here. Forget that I have the Pong project on Linux. Like, I obviously do have it because I showed you all some demos with that, but you don't need it, okay? So just forget I have it. So now that I've opened up VS Code, I have the link generated from Visual Studio. My friend is in Linux, who I want to help me. They just click this Live Share button, join collaborating session. Because it's on the same machine, that link is now auto-pasted in there. Otherwise, you would just send it to them or write it on paper, however you prefer your security. And now what's going to happen is this folder directory over here is going to, from the Solution Explorer, is now going to transfer over to VS Code and appear in there. And then whatever file that I click on, oops, let me go to here. So once I click on like pong.cpp, for example, it's actually copying that file over for me to use over here. And so I've got my IntelliSense. If I'm on Linux and I prefer VS Code, like I'm in VS Code already, my familiar environments. And let me try to make this go like half screen for the full effect. So on Windows, I could be like, hey man, what's going on with these? And then over in the VS Code side, you can see where that partner is highlighting that text. Same if I'm on VS Code and I highlight something, you can see me over on my friend's Visual Studio session in Windows. So this is Windows Visual Studio hosting a VS Code on Linux guest. Pretty nice. And for example, let's see, I can do like, I can right-click on this and say go to definition, and it takes me to the definition. So even though I don't have any of these files locally on Linux, I'm able to do things like go to definition during this session. And one last thing that I want to show about Live Share is if I go into this Live Share button on the side here, and I click on this circle, now I'm actually, you might have seen that, maybe not, but it actually jumped to where my companion was. And so now it'll actually follow wherever they go. So if you're like doing peer programming and you want to see what they're looking at, it'll actually make sure that it's on that screen for you. So that's a feature that's going to be part of Visual Studio 2019 for C++ called Live Share. And as you can see, it works Linux to Windows, Windows to Linux, Visual Studio to VS Code. It's really sweet. Awesome feature. Yeah, you're live editing. Oh, did I not show any edits? I done goofed. For example, I'm typing. You can see it. Oh, you might have been able to see it. Yeah, over here, we can do, like as I'm typing over in VS Code, it's giving me like auto-completion as well, but then also the person in Windows can see what I'm typing. So yeah, it's awesome. So definitely look forward to that. All right, that's enough of the Visual Studio 2019 stuff before anything goes wrong. Oh, and so I exited out of that session. So obviously, if you're the host, you can end your session at any time. And if you exit out of the code, now it's basically telling my Linux buddy that, hey, your pal just left, so you can no longer edit his stuff. But yeah, so that's live share. And now, let's swing back into our slides, because that was a lot of content. And so here's Pong. If I can show the current slide. There we go. All right, so let's just recap what we saw with just that Pong demo. So we saw Vcpkg on Windows and Linux. We saw how it integrates with CMake with that toolchain file. We saw VS Code building and debugging on Linux. We saw CMake with no platform-specific switches. That was actually the part in that Vcpkg spat out with the find package text. I actually forgot to show where that goes, but we saw that. Visual Studio using CMake to target Windows and Linux. We saw Visual Studio debugging on Windows and Linux. And then the last thing that we saw, platform-specific IntelliSense, so that was the purple squiggles. And then finally, live share, which was part of Visual Studio 2019. So that's a lot of cross-platform stuff that we saw just in that Pong demo. But we're not done yet. So let me actually make sure that I exit out of the PowerPoint presentation thing so I can. All right, sweet. All right. So we'll hop back into Visual Studio 2017. And I just want to show you a couple things with this bigger CMake project. First is, over on the side, we have all of our folders and stuff, obviously, but this project actually has way more than just one target. It's got a bunch of different CMake targets in there. And so what we did was we created this CMake targets view to make looking at your code a bit easier in the Solution Explorer. So this actually now shows me all the targets in my project. It'll show the references to the various other files in there. And it also obviously has your source code. And this is just a nice, easy view to work with. And actually, you may notice up here in the debug target, if I select what I want to debug, it actually bolds that text. I don't know if you can appreciate that on the projector, but it actually bolds it over in your target just to help keep things straight in your head and make navigation easier. So I could double-click on this main OpenGL single example CPP file. That would be totally dandy. I can go through this whole tree to get there. But if I already know the name of it, I could just do go to, click F for file, and then type main open, and there it is. So I can just get to the file immediately by using go to, and then F to filter my search to just files. So it's a nice way to just get a little bit more productive as you're navigating your files. And let's go ahead and go to line 75. If I put a breakpoint here, we can hopefully start this debug session and hit it. All right, so I want to show you a nice little debugging feature. We have this vector here that I've pushed 1, 2, 3, 4 onto. And in like other products or something, if you hover over vector, you might not get the most useful information. But if I hover over vector here, you'll see this debug visualizer. And it actually shows me what's inside of that vector. So you can see 1, 2, 3, 4. Shows me what's in that vector at that point in my debugging session. Super nice to have. And then we've got this bullet standalone example is the first parameter in this function here. So if I step into that with F11, and I hover over title, it actually shows, I don't know if you can read the text, but it actually shows me bullet standalone example. So all the debugging tools are working really nicely. And if I were to hover over a line here, you might see there's like a green arrow. I click that, it actually moves the instruction pointer, my debugging session runs up until that point. So that's another tip that not many people know about, these green arrows that appear when you start hovering over text. So that eliminates the need to put a new breakpoint and then say like continue, then put another breakpoint, continue. You can just click in the margin and it'll run execution to that point. So that's another nice little debugging trick. Lastly, let's go into test, Windows. Lastly, test. Yeah, why is everyone always saying testing for last? All right. So this is the Test Explorer, and I thought I already built this project. All right. I guess it's still running. But all right, as of Visual Studio 2017 15.5, I believe, as soon as you build a project, we'll automatically detect any obviously Microsoft framework tests that you have, but also Google tests and Boost tests. Not sure why it didn't show up here. Oh, there we go. All right, so right over here, let's go ahead and just click on one of these. So if I click on this, you'll actually see this is a Google test, and it's appearing in the Test Explorer. If I put a breakpoint on line 11 here, I can right-click, say debug selected test, and I should hopefully hit that breakpoint. Yep. So now I'm debugging that test, and if I were to just continue that, now over in the Test Explorer, you can see with the green check marks, the test passed, and another somewhat new feature here that you might notice is this green check mark above the test. So actually, if I didn't even have this window open, I can see that that test is passed, and if I click it, I can run and debug just from that code lens. It's called Code Lens for unit testing, and that's got that status indicator there. All right. So let's swing back into the slides. Just a recap of what we saw with the bullet demo. So we saw the CMake targets view, which was a nice view to show us all of our targets and the references. We saw the Test Explorer with Google Test, but again, it also supports Boost Test and the Microsoft Test Framework right out of the box. And we saw the debug visualizer when we hovered over vector, and a few productivity tips for like going to the file or going to the line number, and then also that green run to button while we're debugging. Alrighty. So the last thing I want to show for debugging is a project called OpenSCAD. It's a 3D printing software. So I've already got it installed over here. Let me get into that folder. OK. All right, so I've started running OpenSCAD, so the process is already running. And the scenario I want to show you now is, let's say you're in Windows, and I already showed how you can target Linux, and you can launch that Pong process onto your Linux VM. But let's say there's a process already running on Linux, OK? And you're in Windows, and you want to debug it. Well, if I open up, I'm just going to open up the source of that project. And again, well, not again, I didn't actually say this. So OpenSCAD is a CMake project, not CMake. And I went through their instructions on GitHub for how to build it. But one thing I want to point out is after I ran the CMake command, I actually went into the make file, and I put a -G on the C flags and the CXX flags line, because it was just the simplest way that I could figure out how to get my debug symbols into Visual Studio. I couldn't figure it out from their instructions. So just if you're having difficulty with that, just think about going to the make file and adding that -G in there. All right. So I'm going to open up main win. I think it was called. Yeah. And if I go down to like line, I think it was 1258 or something. Yeah, so down in here, you can see a bunch of the different actions. So here's like the open action. So if I put a breakpoint on 1281, we'll see if I can hit this by attaching to a process already running in Linux. We're going to see if I can hit this local breakpoint on Windows. So once again, I'm relying on that connection manager where I set up the SSH connection to my Linux box. And now with that, I can go into attach to process. My connection type, you're going to want to choose SSH instead of default. And then my target is already in here, this VM. And a nifty newish feature is this filtering for processes. So if I start typing, I can actually see here's the OpenSCAD process that I want to attach to. And we'll choose native GDB because C++. All right. And now this is going to allow me to attach, except that it won't, because we got an error. So what's happening here is that Linux is not cool with me attaching to a process that I didn't spawn, right? I didn't start this process on Linux, so it's not going to let me attach to it. But no worries. We'll just swing on over here, open up a new terminal, and I've got this nifty little command here. Oops, what did I click? Oh, I clicked read only somehow. So, all right, I'm going to paste this command in here, and this is going to temporarily disable the security measures so that I can connect. But don't fear. If you want to re-enable it, you just switch the echo 0 to echo 1. It'll flip the security right back on. Also, if you restart the machine, the security is going to be on there again. So now I should hopefully be able to actually attach this thing. All right, I've already filtered. Negative GDB. All right. Ideally, all right, so we're initializing the debugger. And it looks like we're good to go. So I should be attached now. So if I go in here, and let's say I open up logo. All right, so I opened up that logo SCAD file, and it hit this breakpoint for open file in Visual Studio. So we actually managed to hit a local breakpoint in our Windows code here for a process that was already launched in Linux. So that's definitely a debugging scenario that could be useful to a lot of different people. And we'll just swing into here one more time. All right, so OpenSCAD, what we saw was open folder in Visual Studio. So we just opened up an arbitrary folder of code, just the source folder. We saw attached to process, and then we saw hitting a breakpoint in the local source for a process that was already running in Linux. All right, that was a lot of different cross-platform scenarios. So just, I know it was a lot of information to have just given to you all at once. I just wanted to show as much as I could. But this blog down here at the bottom, that's our Visual C blog. And a lot of the stuff I talked about has a relevant blog post for it. So you can actually read some text about it, which would definitely be helpful. Otherwise, you can follow me on Twitter or follow our Visual C team on Twitter. Reach out to us on there if you have any more questions. We're also going to have time for questions here, obviously. But after the conference, if you need to reach out, definitely do that. But yeah, that's it. Cross-platform development.